is superposition theorem. We will discuss today about superposition theorem. What is superposition theorem, or when we use superposition theorem? If a circuit is very simple, that means a circuit contains one voltage source or one current source, so it is very easy to find out the voltage across an element or current across an element. Suppose you take a 12 volt source and you connect 2 or 3 resistors and you measure the voltage across the resistors or current across the resistors, then it is very simple. By the use of Ohm's law and by applying simple formula like KVL, Kirchhoff's voltage law, or your current division rule, as I have told you in the previous class about voltage division rule and current division rule. So you using voltage division rule and current division rule, you can find out the voltages and currents in a resistor in simple circuits. But if the circuit contains more than one voltage sources or many voltage sources and more than one current sources, then it is not simple to find out the voltages and currents through different elements in the circuit. Is not it? So in this case, we apply superposition theorem. That means superposition theorem is useful if any circuit contains more voltage sources and more current sources, more than one voltage sources and more than one current sources. So I will explain superposition theorem taking 3 resistances. Okay, I have done the experiment on superposition theorem. I will provide you the link in this video. I will provide you the link. You, for simple application of superposition theorem, you take 3 resistances. I have taken 3 resistances of 50 ohm and 10 ohm. Okay, you take 2 resistors. One is suppose say 50 ohm connected in series with another 50 ohm resistance, and you take another 10 ohm resistance which is connected in between the two 50 ohm resistances. You take one 50 ohm resistance, then another 50 ohm resistance, then in between the two resistances you take a 10 ohm resistance. That means the 3 resistances are in the form of a T. The 3 resistances are in the form of a T. So you will have one input at the beginning and at the end also, or output you have also another input. Is not it? If you have a T having 3 resistances, 2 resistances in series, and at the middle you have another resistance, then you have 2 inputs. At this side you have one input, and at this side also you have one input. So 2 inputs are there. So in one input, let us say the left input, you take a 12 volt source. Okay, you take a 12 volt DC source, and in the other input you take a 5 volt DC source. So you will have how many number of voltage sources in this simple circuit? You will have 2 number of voltage sources. Is not it? Then there are how many number of current sources? You remember, if any resistor is connected to a voltage source, then that resistor will also be act as a current source, simple current source. So for simple current source, what you do, you take any resistor and connect it to a voltage source. So we have taken 3 resistors. That means we have 3 current sources. Okay. So in the circuit we have 2 voltage sources, one of 12 volt, another of 5 volt, and 3 current sources across the resistance 50 ohm. You have one current source, another 50 for the another 50 ohm resistance. You have another current source, and for the 10 ohm resistance, which is in the middle, okay, that is another the third current source. So you have 3 current sources and 2 voltage sources. And you should know, when you have voltage source and you measure the voltage, you connect the voltmeter in parallel to the circuit. Okay. So when you measure the voltage, you connect the voltmeter parallel to the circuit. And when you measure the current, you connect the ammeter in series to the circuit. Okay. So for 3 resistances, that means 3 current sources, you connect the ammeter in series. You take any, you cut the resistor or cut the wire which is connected to the resistor, and you have 2 terminals, and you connect the 2 terminals with the ammeter. You can easily measure the current. Is not it? So now we will apply the superposition theorem. So how we will apply the superposition theorem? So what is superposition theorem? As I have told you in the previous video about Thevenin's theorem, I have also told you about the Norton's theorem. For these theorems, network theorems, the circuit, remember the circuit must be linear. Okay. The circuit must be linear and bilateral. Remember these 2 words. The circuit must be linear and the circuit must be bilateral. Linear means the circuit contains linear elements. Like your resistors, capacitors, they are linear elements where you can apply Ohm's law. If you take a diode or transistor in the circuit, you cannot apply these laws because they are not linear elements, linear components, they are non-linear. Because you cannot apply Ohm's law to a diode, you cannot apply Ohm's law to a transistor. They are not linear. Is not it? Their VI graph is not a straight line, not linear. So you cannot apply the circuits, in the circuits, these laws, that is Thevenin's law, your Norton's law, your superposition law or theorem. So first condition is the circuit must be linear, and the second condition is the circuit must be bilateral. Bilateral means the current through the circuit or through any component must be same in both the direction. Suppose you take a resistor and allow current to flow from this side to this side, and allow current flow from this side to this side, opposite side. In both the cases, in bilateral circuit, in both the cases, the current flow will be same. If the current flow will be same, then it will be bilateral. That means in both the direction, the current flow must be same. So for superposition theorem to apply, the circuit must be linear and the circuit must be bilateral. Okay. Then what is the definition? For a linear and bilateral circuit, the voltage across an element or current through the element is equal to the algebraic sum of voltages and currents produced independently by each source. Okay. That means if you have 2 voltage sources in a linear and bilateral circuit, you have two voltage sources. So what you do, you first take one voltage source and short circuit the terminals of the second voltage source. Okay, you take the first voltage source and short circuit the second voltage source, and you measure the current and potential through any component. Suppose you take a resistor, you measure the current and voltage by taking one voltage source. Suppose the 12 voltage, so you take 12 voltage source and you short circuit the 5 voltage source. Okay, and measure the current and current and voltage across any resistance. Similarly, what you do, you short circuit the first voltage source. Suppose 12 voltage source you have taken, so you short circuit the 12 voltage source and you take the 5 voltage source, 5 volt, the source of 5 volt, and measure the current and voltage. In any resistance, you measure the current and resistance. Now what you do, you take the two voltage sources. That means 5 voltage source and your 12 voltage source. You connect both the voltage sources. And now you measure the voltage and current through the element. Okay. And you add the readings taken in the previous case. That means in individual case. When you take the individual voltage and voltage sources, you have taken the reading. Now you connect both the voltage sources and you take the reading. The algebraic sum of the voltage sources in the individual case must be equal to the current and voltage when both the sources are connected. So this is the statement of your superposition theorem, that is, in a linear and bilateral circuit, the voltage across an element or current through the element is equal to algebraic sum of voltages or currents produced independently by each source. Okay, so you take each independent source and measure the respective voltage and current, and you take the whole source. That means if you have 3 number of sources, you connect 3 number of voltage sources and measure the respective current and voltage. If the current and voltage in the individual sources, you add the respective voltage and current in case of the individual sources, that must be equal to the voltage and current when all the sources are connected together. So this is the what you say superposition theorem. So superposition theorem is very useful in complicated circuit. I am giving you a tip. Suppose you take, as I have told you, 3 resistances. One is your 50 ohm resistance, then you connect another 50 ohm resistance, and in the middle you take 10 ohm resistance. Okay. Now you connect a 12 voltage source, 12 volt source, and you short circuit the 5 voltage source. Okay. Suppose the first resistor is R1, this is your R2, and this is your R3, 3 resistors. So first you calculate what will be the current through R1, that means 50 ohm resistance, what will be the current, and the voltage is equal to 12 volt. Now you calculate what will be the current. What will be the current? How you can find out? You first calculate the effective resistance, the total resistance, that is R1, suppose R2 and R3. You have 3 resistors, so you first calculate the effective resistance or total resistance. And how you can measure the current? By simply the application of the Ohm's law, V equal to IR. So I equal to V divided by R. So voltage is equal to 12 volt divided by the effective resistance of the 3. That will give you the current through the first resistor or resistor R1. Then how you can find out the currents in the other 2? I have told you in the previous class, before superposition theorem, you must have idea about current division rule. I have explained it in the previous video. So how you can find out the current without having voltage? You have no voltage, only you have 12 volt at the beginning, but at the branch you have no voltage. So how you can find out? By the simple application of your current division rule. So apply your current division rule and find out the respective currents in the other two. Okay. So after finding the currents, that is I1, I2 and I3, suppose I1, I2 and I3, you record it. Similarly, you also calculate the current I1, I2 and I3 by taking the 5 volt source. You short circuit your 12 volt source and you take your 5 volt source and calculate the current I1, I2 and I3. Okay. Now what you do? You connect both. Now you connect both 12 volt source and 5 volt source. And now you measure I1, I2, I3. Okay. And that current must be equal to algebraic sum of the currents what you have found out in taking the source independent. So that is the theme of your superposition theorem. Okay. So you do it. You do this simple circuit at home or in the laboratory. I have done it and I will give you the link in this video. So you see the experiment and you work out some problems. Unless you work out some problems on in physics, you will not go through it. So work out some problem on it, and these theorems are very useful to simplify complicated circuits or to do problems in your entrance examination. In entrance examination also this theorem will be very useful. So you do problems and write to me in the comment section. Thank you.